When installing two 20-inch panel boards on adjacent walls, they can indeed be butted together while still maintaining the required 30-inch working clearance. The key to understanding this lies in how the working clearance is measured. The 30-inch clearance, as mandated by electrical codes, is measured from the outer edge of the electrical equipment. In this specific scenario, the electrical equipment in question is the panel boards. Therefore, the measurement is taken from the outermost point of one panel board to the outermost point of the space opposite it. As long as that distance is at least 30 inches, the requirement is satisfied. Crucially, the measurement is not taken from the center of one panel board to the center of the other. This distinction is important as it allows for efficient use of space while adhering to safety standards. Now, to address the question of minimum side clearance between panel boards, the answer is that there is no explicitly stated minimum side clearance required by prevailing electrical codes. The primary concern is the working clearance in front of the equipment, ensuring that electricians and other qualified personnel have sufficient space to safely access and work on the panel boards. However, it is vital to remember that while there might not be a specific minimum side clearance mandated, other considerations can influence the placement and spacing of panel boards. Firstly, consider manufacturer's instructions. Panel board manufacturers often provide specific guidelines regarding installation, including recommended spacing for proper ventilation and heat dissipation. Adhering to these instructions is crucial for maintaining the equipment's performance and longevity. Secondly, think about conduit entry and exit. The placement of panel boards must allow for adequate space for the installation of conduits and wiring. Sufficient space should be available for bending conduit, pulling wires, and making connections without putting undue stress on the conductors or the equipment itself. Thirdly, consider accessibility. While there might not be a minimum side clearance requirement, the panel boards must be readily accessible for maintenance, repairs, and inspections. Obstructions that hinder access to the panel boards can create safety hazards and impede necessary work. Fourthly, think about future expansion. When planning the installation of panel boards, it is wise to consider the possibility of future expansion. Leaving some additional space around the panel boards can facilitate the addition of new circuits or equipment without requiring major modifications to the existing installation. Fifthly, consider local amendments. Local jurisdictions may have their own amendments to the National Electrical Code that impose additional requirements or restrictions on the installation of panel boards. It is important to consult with local authorities to ensure compliance with all applicable regulations. In summary, while two 20-inch panel boards can be butted together and still meet the 30-inch working clearance requirement, and while there is no specific minimum side clearance mandated, various factors should be taken into account to ensure a safe, functional, and code-compliant installation. These factors include manufacturer's instructions, conduit entry and exit, accessibility, future expansion, and local amendments. Ignoring these considerations can lead to unsafe conditions, code violations, and potential problems down the road. It's essential to prioritize safety and compliance when working with electrical equipment, and to consult with qualified professionals if you have any doubts or questions. The electrical code is a comprehensive set of rules and regulations designed to ensure the safe installation and operation of electrical systems. These rules are constantly evolving to keep pace with technological advancements and emerging safety concerns. Therefore, it is essential to stay up to date on the latest code requirements and to consult with qualified professionals when planning or performing any electrical work. Understanding the nuances of electrical codes, such as the working clearance requirements for panel boards, is crucial for ensuring the safety of people and property. By adhering to these codes and best practices, we can minimize the risk of electrical hazards and create a safer environment for everyone. Let's delve a bit deeper into specific aspects of panel board installations and working clearances. Consider the height of the panel board. The top of the panel board typically has a maximum height restriction as dictated by the NEC, usually around 6 feet 7 inches to the highest operating handle of a breaker. This is to ensure that individuals of average height can safely operate the breakers within the panel. Consider the depth of the working space. The NEC specifies minimum depths for working spaces based on voltage levels. For example, for systems operating at 150 volts to ground, a minimum depth of 3 feet is typically required. This depth increases with higher voltage levels. Consider the illumination of the working space. Adequate lighting is essential for safe and effective work in electrical spaces. The NEC requires sufficient illumination to be provided in working spaces around electrical equipment. Consider the headroom within the working space. Sufficient headroom is necessary to allow workers to stand upright and move freely within the working space. The NEC typically requires a minimum headroom of 6 feet 4 inches within working spaces. Remember, the goal of working clearances is to provide a safe and unobstructed space for qualified personnel to perform their work on electrical equipment. This includes tasks such as inspecting, maintaining, repairing, and operating the equipment. By adhering to these clearance requirements, we can significantly reduce the risk of electrical shock, arc flash, and other hazards. Also, consider the type of enclosure the panel board is housed in. The environment plays a crucial role in selecting the appropriate enclosure. For example, in damp or wet locations, an M3R4 enclosure is typically required to protect the panel board from moisture. In hazardous locations, such as those with explosive gases or dusts, specialized enclosures are necessary to prevent ignition. Next, consider the available fault current at the panel board location. The panel board must have a short circuit current rating SCCR that is equal to or greater than the available fault current. This is essential to prevent the panel board from failing catastrophically in the event of a short circuit. Now let's talk about grounding and bonding. Proper grounding and bonding are critical for electrical safety. The panel board must be properly grounded to provide a low impedance path for fault currents, helping to trip circuit breakers and prevent electrical shock. Bonding ensures that all metallic parts of the electrical system are at the same potential, minimizing the risk of shock. Consider the size and type of conductors used for the panel board feeders. The conductors must be sized appropriately to carry the load current and must be protected by overcurrent devices, such as circuit breakers or fuses. The type of conductors used must be suitable for the application and the environmental conditions. Also think about the labeling of circuits. Clear and accurate labeling of circuits is essential for safe and efficient operation of the electrical system. Each circuit breaker must be labeled to indicate the equipment or area it serves. Consider the use of arc fault circuit interrupters, also known as FSIs. FSIs are designed to detect arc faults, which are a common cause of electrical fires. The NEC requires FSIs to be installed in certain circuits, such as those serving bedrooms and other living areas. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock. The NEC requires GFCIs to be installed in certain locations, such as bathrooms, kitchens, and outdoor areas. Don't forget about surge protection. Surge protective devices, also known as SPD, are designed to protect electrical equipment from voltage surges which can be caused by lightning strikes or other events. SPD should be installed at the main service entrance and at downstream panel boards. In summary, panel board installations involve a multitude of considerations ranging from working clearances to grounding and bonding. By carefully planning and executing the installation, and by adhering to all applicable codes and standards, we can ensure a safe and reliable electrical system. The electrical code is updated regularly to reflect new technologies and safety concerns. It is essential to stay informed about the latest code requirements and to consult with qualified professionals when planning or performing any electrical work. Always remember that electricity is a powerful force that can be dangerous if not handled properly. Prioritize safety and compliance in all electrical work, and never hesitate to seek expert advice when needed. Panel boards play a crucial role in distributing electrical power throughout the building. They are the central point for branching out circuits to various loads, such as lighting, appliances, and equipment. A well-designed and properly installed panel board is essential for ensuring the safe and reliable operation of the electrical system. Consider the load calculations. Accurate load calculations are essential for determining the appropriate size of the panel board and the feeder conductors. The load calculation must take into account all of the connected loads, as well as any anticipated future loads. Think about voltage drop. Voltage drop is the reduction in voltage that occurs as electrical current flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Conductors must be sized appropriately to minimize voltage drop. Also, consider the ambient temperature. The ambient temperature can affect the ampacity of conductors and the performance of electrical equipment. Conductors must be derated if they are installed in high-temperature environments. Then there's the harmonic distortion. Harmonic distortion is a form of electrical pollution that can cause problems with sensitive electronic equipment. Harmonic filters may be necessary in some applications to reduce harmonic distortion. Remember coordination. Overcurrent protective devices such as circuit breakers and fuses must be properly coordinated to ensure that only the faulted circuit is interrupted. This helps to prevent unnecessary outages and minimize downtime. And consider selective coordination. Selective coordination is a more advanced form of coordination that ensures that the overcurrent protective device closest to the fault will trip first, while upstream devices remain closed. This is essential for critical applications such as hospitals and data centers. Let's not forget about arc flash hazard analysis. An arc flash hazard analysis is a study that identifies potential arc flash hazards and determines the appropriate personal protective equipment (PPE) that must be worn by workers who are exposed to these hazards. Arc flash hazard analysis is often overlooked, but it is an important part of electrical safety. Let's consider the use of remote racking systems. Remote racking systems allow workers to operate circuit breakers from a safe distance, reducing the risk of arc flash exposure. Then there's the use of infrared scanning. Infrared scanning can be used to detect hotspots in electrical equipment, which can be an early warning sign of potential problems. Regular infrared scanning can help to prevent equipment failures and improve electrical safety. Lastly, think about the need for regular maintenance. Regular maintenance is essential for ensuring the safe and reliable operation of panel boards and other electrical equipment. Maintenance should include inspecting, cleaning, and testing the equipment,